All right. Okay. So yeah, please confirm if you can hear me now. Okay, very well then. Yes, everything is nice and clear. Okay. So yes, today's topic of discussion, guys, is going to be chapter number 24 from Clayden Organic Chemistry, and you know that this is a very important chapter. ठीक है? It's going to be based on regioselectivity. All right. Okay. Good morning, all of you. Once again, welcome to Unacademy. And we have had a lot of sessions on in this series, guys. बहुत सारे important chapters है जो हमने कर लिए हैं, which is from this book. Now, see what happens from this chapter and from the next chapter, right? The level is going to increase a little bit. So, for all those who are joining now, मतलब कि जिन्होंने पहले वाले सेशन नहीं देखे हैं, right? Please go and watch the basic chapters once, and then we are going to, and then you can move onwards to these ones, right? And yes. This is chapter number 24. We haven't studied all 24 chapters, but we have only talked about the important ones. And most importantly, from Clayden, what do you get? Clayden से हमें सबसे ज्यादा important information मिलती है about all the reaction mechanism. So it's a best book for understanding the reaction mechanism and getting a lot of good practice questions in the solution manual. So I just hope that after watching all of these session, you're also reading the chapter and solving from the solution manual. That is how you develop your organic chemistry. Okay, so yeah, first thing first, ये जो chapter है ना, regioselectivity, guys, it is a sum up of everything that we have already studied. Why? Because सारे जितने भी reaction mechanism हमने पढ़े हैं, right? All the reaction mechanisms, always there is some kind of regioselectivity going on in that mechanism, and that is why for the regioselectivity you have a major and a minor product, isn't it? Because of regioselectivity, or actually we must say that because of selectivity term, we have a major and a minor product. It could be regioselectivity, it could be stereoselectivity, it could be chemoselectivity. Three types of selectivity you have. Okay, so yeah, because of the selectivity term, you have a major and a minor product. Okay, then. So, what are we talking about in this chapter? Mostly everything that we have studied, this is a sum up of everything, and regioselectivity is not limited to the reactions that we study over here. What are we going to study? We'll study that why an alkene will give you two different products. That is, when you are adding to an unsymmetric alkene like this. Okay, addition of a unsymmetric reagent, that is your HX, let's say HCl or HBr, something like that. Why is it going to give you two different products in this way? Where is the position of X? Acha, so tell me one thing, what does regioselectivity give you? Does that give you positional isomers as products? Yes or no? So because of regioselectivity, that is the selection of region where the X and the H goes, that will give you positional isomers. Yes, just like stereoselectivity will give you either diastereomer or enantiomer, regioselectivity will give you positional isomers. All right then. Similarly, we look at the reaction of an epoxide. How is the epoxide going to open? Right, where is this nucleophile going to attack? It can attack over here as well, it can attack over here. So there are two ways in which the epoxide can open up. We can study this reaction. We can also study a very popularly discussed addition of an electrophile to the diene. ये देखो diene के ऊपर कैसे addition होता है, and once again it gives you two products. This is one of the product 1,2 addition, and this is another product 1,4 addition. We call it 1,2 addition. This one we call 1,4 addition, isn't it? And similarly, conjugate addition onto the enone system. ये हो गया है enone system, and this one we have already talked about in just the previous session, chapter number 22. If you want, you can check out. ठीक है, so where is this nucleophile going to attack? Will it attack on the carbonyl carbon, or is it going to attack on the fourth position, the alkene carbon? ठीक है, absolutely, that gives you two products. Once again, the 1 2 and the 1 4 product. Okay, so yeah, basically this is what we are talking about. Now the most important point is, how are we going to understand, how are we going to know that which reaction is going to give you which product? Absolutely, you have to see more examples and you have to read more. That's how you're going to understand, and you have to observe more in the reactions. So it's going to be a collection of what we have already studied, isn't it? Yes. So first thing first, regioselectivity in the electrophilic aromatic substitution. So haven't we studied this chapter very recently? Electrophilic aromatic substitution. Very recently we have studied this chapter, and we saw that if, let's say, our benzene is already substituted, it is having a CF3 group. So if the benzene is already substituted, then it must have some directing property on the incoming electrophile. Who is the incoming electrophile? That's going to be the nitronium ion. Yes, so it will have a directing property. So we know that electron withdrawing groups are meta directing in nature. Why are they meta directing? That also we have discussed. So the meta directing property to give you one single regioisomer, this is called regioselectivity. 96% yield and you are getting only meta product. No ortho, no para. Similarly, if you are taking aniline, we have discussed this also, कि aniline में if you are doing bromination in the presence of bromine water, since nitrogen is very electron rich, very electron donating, it's going to make this ring very electron rich, और क्या हो जाएगा? Tribromination. You will get a tribromoaniline product. Absolutely. Similarly, if you add acyl group on the nitrogen, what did you get? You got कि चलो यहाँ पे reactivity कम हो गई है, nitrogen is less reactive over here, and hence it's going to only give you a para product. 84% yield and you get only para product. All right. So once again, ortho, meta, para, all of these are regioisomers of each other. Do you agree? They are all regioisomers of each other and they are obtained by different set of reaction conditions and the directing group. Yes, absolutely. Okay. So ये जो भी हम reaction करवाते हैं ना, जो भी हम selectivity induce, sometimes we induce selectivity, right? So that all of it is regioselectivity. We want some group to attach to some position of a molecule. That position, whenever we talk about position, that is going to be region or regioisomer, regioselectivity. Absolutely. Okay then. So there are a lot of reaction. हर टाइप के रिएक्शन में आप regioselectivity निकाल सकते हो. Here we are not talking about the Diels-Alder reaction. There also you have regioselectivity, and photochemical reactions also, cycloaddition, every particular reaction has regioselectivity. Just that when you why are we studying this? Because अगली बार आप कोई भी reaction पढ़ो तो आप इस चीज पे ध्यान दो, and you kind of try to figure it out that how is it going to matter, how are we going to get different products, different positional isomers under different conditions. So yeah, this is one of them. Sulfonation. This leads to orthoselectivity without lithiation. Now, what is lithiation? That also we will talk about. Lithiation क्या होता है? We have a good question on lithiation to solve today. Okay. Yeah, what is lithiation? We'll see later. First thing, let's say we are kind of inducing regioselectivity. Induce करना मतलब क्या होता है? Let's see that. So on phenol, we are taking concentrated H2SO4, which is going to give you the sulfonium electrophile, which will be attacked by the phenol molecule to give you the ortho and the para product. Both of these products, because phenol is electron rich. Okay then, so you got ortho and para product. This is the regioselectivity already, but because of these two groups, अब जो ये OH है, it can only bring forward. Now the OH has to be deprotonated to make this ring more electron rich, क्योंकि because of the sulfonyl group, it is having a lot of resonance inside the ring. Yes, inside the ring. So ये OH जो है ये electron deficient हो जाता है. So you have to convert it into O minus, SO3 minus. All of these will be converted into minus in the presence of a base, and bromination will happen on the next ortho position, which is left out, right? And after that, 200 degree centigrade पे distill the product, removal of this sulfonyl groups, sulfide groups, and you get ortho-bromo product. So it's not possible for phenol to give you a single ortho-bromo product. Why? Because just like aniline, it is very electron rich, और ये क्या करता है, ये भी क्या करता है, ब्रोमो ट्राई ब्रोमो प्रोडक्ट दे देता है, just like aniline gives you a tribromo product like this. So if we want to get some regioselectivity, if we want to induce some selectivity, so that's why we are using sulfonation as an agent, or sulfonation as a pathway to only get the ortho-bromo product. Okay? So what is the mechanism that is shown over here? A very simple one. That is, how is the desulfonation taking place? ये वाला जो स्टेप है ये ऐसे है कि सल्फोनिल ग्रुप रिमूव कैसे होता है. So it's removing as SO3 gas, and it is plain electrophilic substitution. It is plain electrophilic aromatic substitution, just like we have been doing for removing the proton with sulfonyl group, right? So as you can see, a proton is taken away by the phenol on the same position as the sulfonyl group, and here the sulfonyl will leave its electron density to give you sulfur trioxide, and similar for this one to give you the product. Okay, yes, absolutely, very, very simple. Now, if we talk about the regioselective reactions of naphthalene, how many of you have seen this? The kinetic and the thermodynamic product, that is in the presence of H2SO4 at 10 degree centigrade, or let's say lower temperature, 40 degree, 10 degree will be lower only. So that gives you the alpha uh, naphthalene sulfonic acid. Right, so that gives you alpha naphthalene sulfonic acid, or at higher temperature 160 degrees centigrade gives you beta naphthalene sulfonic acid. Yes, ये किसने किसने देखा है. So what is the kinetic product? A kinetic product is one which forms at lower temperature, and a thermodynamic product is one which is more stable, and that is why it requires higher activation energy and high temperature to form, but it is not reversible. जैसे kinetic product reversible होता है, thermodynamic product is not reversible. Okay, that's the benefit. All right, so we have all studied this reaction. It's a very simple one, right? Now, why does it happen? The reason, you know, that when you are looking at the most electron rich position, or let's say when you are looking at a stable carbocation, let's understand what must have happened with naphthalene. अगर naphthalene ने यहाँ से attack किया है, let's say it has attacked over here onto the sulfonyl group, and there is a positive charge on this carbon. Right, very well. So what will happen now? There will be an extended conjugation throughout to stabilize this carbocation. Yes or no? पूरा का पूरा जो है extended conjugated system है to stabilize this carbocation over this charge. So a stable intermediate जहाँ पे इंटरमीडिएट स्टेबल होता है, that will require low activation energy. If we discuss this from the graph, let's say this is your naphthalene, जहाँ पे stable transition state होता है, stable intermediate होता है, you require low activation energy. And when there is a non-stable या unstable intermediate but the product is stable, वहाँ पे higher activation energy चाहिए होती है, and that is why this is your thermodynamic product, this is your kinetic product. Okay, absolutely. Regioselectivity अक्षय सभी रिएक्शन के केस में पॉसिबल है, लेकिन द प्रोमिनेंट इफेक्ट इज सीन ऑन द नैप्थलीन, राइट. बाकी के जो रिएक्शंस होते हैं, दे आर मोस्टली लाइक द ब्रोमिनेशन रिएक्शन, इट्स मोस्टली ऑलवेज गिविंग यू द ट्राइब्रोमो प्रोडक्ट फॉर एनिलीन एंड फॉर फेनॉल, राइट. सो या मेजर डिफरेंस यू सी इन नैप्थलीन. तो अब एक बात बताओ, लेट्स से वी आर टॉकिंग अबाउट beta sulfonation. ये हो गया beta sulfonation. Okay, so there will be a carbocation over here. Now you tell me, looks like cross conjugation, isn't it? Because there is a sp3 carbon in between. तो ये क्या हो जाएगा, एक तरीके से cross conjugation जैसा सिनेरियो है, right? So that's why, yes, that's why this is going to be a less stable intermediate, requires higher energy, and gives you the thermodynamic product. All right, so this was very simple. We had talked about the regioselective reactions of naphthalene giving you a a kinetic product and a thermodynamic product. Okay, talking about the next regioselective reaction in the nucleophilic aromatic substitution. ये तो सबसे ज़्यादा important है, and in the PYQs you get stuck a lot and a lot of times. मैंने हमेशा हमेशा आपको बहुत सारे रिएक्शन कराए हैं based on this, and I don't know guys, for all those who are not there on Unacademy already, I am conducting a lot of free classes every month just so that you get a lot of practice. So please do take benefit of all the free classes. Yeah, right now we are doing organometallics. Okay, so yes, first thing first, अब एक बात बताओ, न्यूक्लियोफिलिक एरोमेटिक सब्स्टिट्यूशन करना है on substituted pyridine. Let's say I want to do it with methoxide. So which chlorine is going to substitute? ये meta वाला chlorine या ortho वाला chlorine? The meta chlorine or the ortho chlorine? Which one is going to get substituted? Yeah, what do you say? Meta or ortho? Ortho, absolutely yes. Why? Because when we draw the mechanism, we have to take care that the nucleophile should attack in such a way that it gets the negative charge on nitrogen. That way it's going to give you a stable intermediate, and when the negative charge falls back, हमारा जो good leaving group है वो leave कर जाएगा. So here the chloride is a good leaving group, and hence it leaves to give you the substitution on this position. So absolutely, this is also a regioselective reaction. Why? Because the orthochlorine is the one which is substituted, not the meta one with respect to nitrogen. That is, I would say कि 2 number पे जो chlorine है, that will be substituted as compared to 3, 4 and 5. Fifth chlorine. Absolutely. Yes, absolutely right. So these are all once again regioselective reactions. Now let's look at simple reaction over here. So somehow you have got 1,2-dichlorobenzene, and from there you want to first of all add a nitro group. हमने nitro कैसे add करते हैं? Electrophilic aromatic substitution करके, so हमने add कर दिया. Okay. Now you have the methoxide once again. Where is this methoxide going to attack? Which chlorine would it substitute? The metachlorine or the parachlorine? Which one do you think? That's the regioselectivity once again. So yes, the meta or the para. And why is that so? Why is it attacking the para chlorine? Why not the meta? Because when you write the resonance structure, see, this is your nitro group, a metachlorine and a parachlorine. So let's say your methoxide has attacked over this position, the para one, right? So that is going to cause resonance right inside the nitro. मतलब कि nitro जो electron withdrawing group है वो electron density ले रहा है, and that is what is assisting this reaction to happen, nucleophilic aromatic substitution. So nucleophilic aromatic substitution always wants to have a electron withdrawing group on the ortho or the para position with respect to the leaving group. Okay, so that's why this is the answer. ठीक है, मेटा क्यों नहीं होता है आभा आपको पता है, ऑलरेडी हमने डिस्कस किया है. दिस इज नॉट द बेंजाइन मैकेनिज्म, ये तो SNAR मैकेनिज्म है. In the SNAR mechanism, you only have ortho and para resonance going right into the electron withdrawing group. Meta position पे अगर nucleophile attack करेगा तो this negative charge is just going to move around into the ring itself. नहीं तो वो एक carbon पे जाएगा. It's not going to go into the nitro. So that's the reason. ठीक है, चलो. So here comes the benzene mechanism. And guys, let me tell you, it does not even end over here. ऐसा नहीं है कि मैंने आपको एक एग्जाम्पल दिखा दिया है रीजियो सिलेक्टिविटी का, so it's over. You get umpteen of examples of regio selectivity of all kinds of mechanism. जितने भी possible mechanism है, चाहे वो substitution हो, NGP हो, elimination and substitute, anything basically, there is a lot of regioselectivity in reaction, and that is what is confusing you in the exam. So yes, here it is benzene mechanism. Okay, so where did we start from? We started from yeah, so let's say we started from this molecule. So if we started from this molecule, why did you only get the meta amino anisole? Yeah, why not ortho? Why did this amine group not go on the ortho? यही क्यों major product हो रहा है? That is once again regioselectivity, isn't it? Yes, right? So that is because when you are generating the benzene by the removal of the only possible proton in this way, और हम benzene generate कर रहे हैं, this is your benzene, very well. After the benzene formation, you will know where is the nucleophile going to attack in such a way as this group can show its effect. या तो ये minus I effect होगा या तो plus I effect होगा. Oxygen, that is the methoxy, always shows minus I. It is not going to show the plus R effect because the benzene carbon is outside the ring. It is not inside. So always for methoxy you will have a minus I effect. So इसीलिए the negative charge must come close to this methoxy, and also this is sterically favored because two big groups are far away. So sterically favored. Which one? The meta product over here, right? So you get the major product from over here. Absolutely. So ये फिर से regioselectivity हो गई, and then you get a lot of regioselective reactions of benzene. Okay then, and what are we proceeding with? यहाँ पे अब बहुत simple है. We are generating HNO2 with this combination NaNO2 and HX nitrous acid, and after that you will form the diazonium compound, and then you give the Sandmeyer reaction or a similar to Sandmeyer reaction, CuCN, removal of this nitrogen through a SN1 type mechanism because there will be a phenyl carbocation over here like this. So ये हमारा एक possibility है. Yes. This is another possibility of regioselectivity in the benzene mechanism. Alright, very good. So guys, what are we going to talk about now? Let's see. क्योंकि हम aromatic rings के बारे में बात कर रहे हैं, we have seen electrophilic aromatic substitution, we have seen regioselectivity in nucleophilic aromatic substitution. एक और बहुत important example देखते हैं. Ortho lithiation. what is ortholithiation? How can we utilize this? Let's see. Using an organometallic compound, that is the butyl lithium. Yes. So, using butyl lithium, you can actually remove the proton which is on the ortho position of a polar group. The group has to be polar. Usually, maximum times you are going to get a methoxy or oxygen या तो nitrogen based group, and most of the times oxygen, क्योंकि oxygen और lithium की binding बहुत strong होती है, right? Yes. So at 20 degree centigrade, butyl lithium is going to do ortholithiation. This is called ortholithiation कि ortho position पे hydrogen को remove करके lithium आ गया है, and along with that you get butane. How does it happen, guys? ये ऐसे होता है कुछ कि this oxygen is going to attract lithium and the butyl group which is actually negative polarity. ये positive और ये delta negative है. So the one which is negative polarity will grab a acidic proton और oxygen यहाँ से इसको chelate कर रहा है, complexation. Oxygen and Lewis acidic lithium, like this. So this is how the reaction happens. You get the ortholithiation and you get butyl hydrogen. That is your butane basically. Alright, simple hydrocarbon. Okay, so what is ortholithiation? जो हमने पिछला रिएक्शन किया था ना कि सल्फोनेशन कैन गिव यू ऑर्थो प्रोडक्ट्स विदाउट ऑर्थोलिथिएशन. Yes. So there we were using a reversible reaction. Sulfonation is a reversible reaction. We were utilizing that, right? Ortholithiation क्या होता है? In the presence of a alkyl lithium, the alkyl group is going to take away this hydrogen and lithium is going to get attached to the ortho position. Yes, Ananya, it's as simple as that. तो हम क्या करेंगे? देखो यहाँ पे क्या है हमारे पास? ऑक्सीजन तो नहीं है, it's a nitrogen. That's still a polar group. So on any of these positions, see, these two positions are equivalent as of now, क्योंकि जब तक इसमें कोई substituent नहीं आ जाता है जो इनको अलग कर दे, they are still the same. Okay. So at any of these positions, either this hydrogen or this hydrogen, they will be removed by the butyl group to give you ortholithiation. Now, what is the use of ortholithiation? Ortholithiation का use ये है, lithium is positive, so this carbon must be negative. Yes or no? Just like you are having methyl magnesium bromide. So just like that you are having methyl lithium, just like that you are having aryl lithium as well. मतलब अब ये जो moiety है, this is going to have a negative charge and it could attack over a carbonyl to give you addition product like this. See what you got. You got a alcohol by after the aqueous acidic workup. Okay, बहुत अच्छे. All right. So this is your very simple reaction, ortholithiation. 73% yield. Okay, now Akshay, see what happens is, why do you use a polar molecule? जैसे हमारे पास HMPA होता है, TMEDA होता है, right? So we use the polar molecules so that the alkyl lithium does not aggregate. Alkyl lithium की ना एक बहुत ही aggregation वाली property होती है, because the lithiums are very small and they can, what should I say, aggregate ना हो, इसलिए TMEDA use होता है so that the reaction could be better. Okay, so yeah, like that. Now here comes the important, very important part, regioselectivity of intramolecular reactions. Yes, so how many of you have done the iodo या फिर bromo lactonization reaction? किसने किसने किया है ये? So many times in the PYQs, in your GATE examination, in your CSIR NET examination, right? bromolactonization, iodolactonization. So yeah, how many of you have done this already? Okay, so बहुत simple mechanism है. What you have to do is just take care of what is happening. See, here we are talking about regio, so don't worry about stereo at all. ठीक है, first understand the regio of this reaction. That is, the double bond is electron rich. So the double bond is supposed to attack on bromine. Yes. What happens is the double bond attacks like this. 1 Br minus eliminates. Yes. So that gives you a bromonium ion in the presence of a mild base, mild enough to remove the acidic proton. Yes, absolutely it can remove the acidic proton, right? इसको हटाने के लिए इतना basic काफी है. So O minus will attack onto this carbon to give you a 5-membered lactone ring, and इस कार्बन पे आ जाएगा bromine. Either bromine or iodine or chlorine, whichever halogen you want to take. Yes, why we always take bromine or iodine? Because they are more polarizable. Yeah, that's why. Okay, that's why we take mostly the more polarizable halogens basically. All right then. Similarly, what does the next reaction give you? ये देखो फिर से. Here you are using an iodine. The iodonium ion is going to form. ये जो OH का H है proton, this will be removed by sodium bicarbonate. ये बन गया O minus. So yeah, the minus is going to attack on this carbon in this way और ये बन जाएगा iodine. 5-membered ring or a gamma lactone once again. You can break it down by adding a strong base. ऐसा जरूरी नहीं है that the lactone will be formed and in the presence of this base only the lactone is going to get hydrolyzed. No. If you take a strong base, तभी जाके it's going to get hydrolyzed. Sometimes what is also mentioned is sometimes you might also get elimination product over here. Okay, let's say I'm using a very strong base. Strong है लेकिन hindered base है because it cannot do the hydrolysis. Lactone hydrolysis नहीं कर सकता. DBU is a very bulky base. Diaza bicycloundecane is the name. So it's only there to take away a proton from here. Let's say. So what is your product going to be? ऐसा कुछ? Yes, right. So DBU is a very strong base, but it cannot do the ester hydrolysis, so it's just going to give you elimination. E2 elimination हो जाएगा, yes. So that could also be possible, and you also have got this in your PYQs a lot of time in the CSIR NET exam, right? A very, very simple mechanism. Okay, then very good. Now we move onwards. All right, now regioselectivity in the elimination reaction. Super, super important. Cannot have enough of regioselectivity in the elimination. Okay. इसके लिए बहुत ज़्यादा example है guys, and if you study only a little bit of Caruthers, if you want to check out, you'll see a lot of examples. Okay, so let's say this is your product of iodolactonization only. This is your iodine, and you can remove 3 of these hydrogens to give you 3 different types of alkenes. Yes or no? But which alkene is going to be the major product? That is the question. अगर हमें green hydrogen को हटाना है, then you get this alkene. Yes, but it's not possible. Alright. Similarly, the loss of the orange hydrogen, that is going to give you this alkene. So why are they not being such a good option? Because ये जो black वाला hydrogen है, this is a more acidic proton. More acidic proton है. So is it going to go under E2 elimination या फिर E1CB? क्या होना चाहिए? E2 है या E1CB है? Guys, we have discussed all of this. So absolutely, when there is a electron withdrawing group, it will be E1CB mechanism, because negative charge gets stabilized, right? And then the I minus will remove. So this is your product, alpha beta enone system. ठीक है? And E1CB is the mechanism. Absolutely. So let's go back and let's check out for this molecule. क्या इसमें possible है? Is it possible in this molecule to get your alpha beta unsaturated molecule? No, only one proton is present which could be removed. और कोई option ही नहीं है. So there is no more option to remove any other proton. Only one proton is present from this carbon which we remove and get this product. Okay then. So I just hope that you have got the hang of what is regioselectivity. Now we will also talk about addition of alkenes. So guys, basically हमने ज़्यादातर जो reaction mechanism वाले chapters है, those we have done. ठीक है? So yeah, electrophilic addition on alkenes. So this is remaining, and after that we might do the epoxide opening also. ठीक है? वो भी हम लोग कर लेंगे. Epoxide opening, regioselectivity in the presence of acid and basic medium. Yeah, let's do this quickly. So what do you understand from hydroboration, guys? Yes, what do you get to know from hydroboration? It's very simple. Just that if you are taking a BH3 molecule, if you want to take a BH3 molecule, the H and the BH2 are going to add on the same side of the double bond. पर वो तो stereoselectivity हुआ ना? That is a stereoselective syn addition. That's a different part. What about the regio? Where will the hydrogen add? Where is the boron going to add? वो question है. Yes. So boron is going to add in such a way that it tries to remain on the less hindered side, least hindered side. Absolutely. ये देखो. BH2 will attach on this carbon. ऐसा क्यों नहीं हुआ? Why? BH2 did not go over here and hydrogen over here, because it's not possible. BH2 will always go on the less hindered side. And this is the same thing that it does 3 times to give you a trialkyl borane. And बाद में इसका oxidation करके you are going to get the same product. कौन सा alcohol है? 1 degree alcohol. 1 degree alcohol. And if you got this alkene, let's say, same alkene you have got. Same alkene को either you do oxymercuration, demercuration, or you do simple hydration in the presence of acid. What is the product that you will get? You will get like this. Basically, you'll get a 2 degree alcohol. Yeah, you'll get a secondary alcohol. Okay, yes, absolutely, guys. So this is what happens. Now, all right, the same mechanism, hydroboration and oxidation, वही सारा mechanism है यहाँ पे. Selectivity, regioselectivity सिर्फ इसमें है कि पहला जो addition है वो कहाँ हो रहा है. After that, the reaction is going to proceed in the similar manner without the change of regioselectivity. Okay, all right. Let's also talk about regioselectivity in the radical reaction. Okay, so this is something extremely and completely different. क्यों? Let's say I'm having an unsymmetrical alkene system over here, and let's say I want to generate through ionic mechanism, I want to make it react with HBr. ये हमने मार्कोनिकॉफ और एंटी मार्कोनिकॉफ रूल में पढ़ा था. That is the addition of HBr to an unsymmetric alkene and the addition of HBr either in the presence of light or in the presence of peroxide that gives you a different product. Do you remember? Yes or no? Alright. ये CH3 हो जाएगा. There will be a positive cation. A tertiary cation will be more favored, and that's why it's going to proceed through this mechanism and give you this product, right? लेकिन radical mechanism में क्या होता है guys? What happens? If you are adding HBr, there will be H radical, there will be Br radical over here like this. Is it necessary that your H radical is going to kind of add to this alkene? Is it necessary? Not at all. Then what? A Br radical will be more reactive. It will react better with this alkene. Br ने पहले react कर लिया है. Now the hydrogen radical can also attack over here to give you directly opposite product. Both of these are directly opposite. ये हो गया है 3 degree bromide. This is your 1 degree bromide, a primary bromide. Okay, so yeah, absolutely all completely different products. Similarly, हम वही चीज कर रहे हैं. To this alkene we are adding a bromine. So how do you add a bromine, guys? In the presence of ionic medium, you form the bromonium ion in this way, और एक Br minus दूसरा वाला अटैक करता है opposite position पे, so that gives you this kind of a molecule. लेकिन Br2 in the presence of light is going to give you a stable radical. First of all, through this alkene, there is a hydrogen over here onto this carbon. जो दो bromine radical form हो रहे हैं, two Br radicals which are forming, one of the Br radical takes away a hydrogen like this. ये निकल आया एक हाइड्रोजन, क्या बन गया? एलाइलिक radical. Yes. So you get the allylic radical. After the allylic radical, one more Br radical remains and that radical is going to form a bond over here. तो ये क्या बन गया guys? Allylic bromination. Okay. So completely different reactions in the radical also. तो ionic और radical mechanism क्या करते हैं? They give you exactly complementary products. Okay, complementary product मतलब जैसे कि एक regio isomer कोई दे रहा है, दूसरा regio isomer कोई दे रहा है, ठीक है? Yes. All right. Now here comes the most important part, electrophilic attack on conjugated dienes. क्योंकि ये थोड़ा confusing है, so we have to have a little bit of patience while we are doing this. Okay? All right. बहुत ज़्यादा important है. So, to a diene system, either this is a fixed, see, this diene over here, ये क्या है? एक rigid fixed diene है. If you are talking about 1,3-butadiene, that's a different system. ये एक fixed diene है. So in the presence of HCl, for example, it's going to give you a hydrogen over here और एक positive charge आ जाएगा इस double bond के इस position पे. Either the Cl minus attacks over here and this will be your direct addition SN1 type mechanism. ठीक है, this is your SN1 type mechanism. ये दूसरा mechanism जो है it is SN2 prime mechanism because it's kind of the allylic mechanism, something like that. Alright, so either mechanism it's going to give you the same allylic chloride product 70 to 90% yield. Same product मिल रहा है यहाँ पे, ठीक है? Similarly, if you have bromine, Br2 I said, right? Bromine. So you will have 1,4 bromine addition as given over here 64%. लेकिन अब ये 1,4 क्या है? ये सिस है, ये ट्रांस है. व्हाट इज दिस? 1,4 ब्रोमीन. लेट्स टॉक अबाउट दिस. एंड ऑल्सो ब्रोमीन की जो रिएक्टिविटी होती है, इज इट गोइंग टू चेंज बेस्ड ऑन द polar and the non-polar solvent that we have? Let's see that. There comes the actual regioselectivity. ये देखो, अगर हमने लिया सेम डाइईन ले लिया है, Br2 alkane solvent, simple alkane solvent में I am getting the same trans the 1,4 addition product जो पीछे हमने देखा था, but here you are getting it trans. Okay, but when -20 डिग्री सेंटीग्रेड पे या फिर at a minus temperature Br2 and chloroforms are added, you are going to get kinetic product which will be दोनों Br same side पे add हो रहे हैं, right? And this, since this is a kinetic product, on standing for 2 weeks it's going to give you the trans product by itself. All right, so yeah, this is basically how the equilibrium is shifting. क्या reaction condition से क्या product आता है, that is the overall important thing over here. Now sometimes it's okay, see, it's okay when you are using the non-polar solvent. पोलर सॉल्वेंट यूज कर लो तब तक भी ठीक है, लेकिन पोलर प्रोटिक सॉल्वेंट यूज करते ही गड़बड़ हो जाएगी. व्हाट इज दैट? सो let's say there's a PYQ in your exam. If you have realized when you're scrolling through the PYQs, ऐसा एक क्वेश्चन एग्जाम में आया था somewhere in 2015 June or December, I don't remember. Bromine addition in the case of either methanol is given or this amine is given. दोनों में से कोई एक दिया है, ठीक है? So either the methanol or the amine. Yeah, what does that give you? That gives you different products, and the major product is going to be like this one. This is your major product, and why is that so? Let's see. So first of all, bromination हो गया है इस molecule के ऊपर, and that gives you this kind of a product. Why? Because it will give you 1,4 addition product. Okay, naturally bromine gives you 1,4 addition, ठीक है? लेकिन क्या होता है इसके बाद? Either it is a cis product, all right, or it is a trans product. Cis हो या trans हो, when there is a polar group added, it is going to remove that Br, और ये Br की को हटा के क्या खुद ऐड हो जाएगा. The solvent itself is going to interfere in the mechanism, और ये बन गया है हमारा 1,2 product. Okay, so that is very very important to understand. And how does it happen, guys? बहुत simple mechanism है, कुछ नहीं है. See, we start with cis or we start with trans. Mechanism is very similar. पहले हमने किया SN2 inversion, that is one of your amines. It will attack on this carbon to give you inversion of bromine like this. And yeah, so stereochemistry has inverted. Now it will do NGP kind of. NGP करने से ये bromine तो निकल गया, right? Bromine निकल गया, उसके बाद में it's going to give you a 3-membered ammonium ion, something like this. Since it is very strained and electron deficient system, what will happen? The amine is going to attack on the second position, and please take care that the amine does not attack on the first one. मॉक टेस्ट में पूछा था, बिल्कुल आएगा. यहाँ पे ये इधर अटैक नहीं कर रहा है. You are getting this major product. And why is that so? This is so because the capacity of nitrogens to stabilize, nitrogen is not very polarizable, isn't it, guys? जैसे हमने पहले पढ़ा था कि bromine तो stabilize कर लेता है. Bromonium ion will stabilize. Why? Because bromine has a lot of polarizability, it's a big one. ऐसे करके stable कर देता है. लेकिन if I write this kind of a cation, NMe2 positive like this, okay, if I write something like this, absolutely it's mostly going to stay in this form. It it is mostly going to stay in this form like this. ठीक है? And that is why a direct addition will be more preferred. ठीक है? Yes. So in whichever case you follow, CSIR trans, whichever case you follow, you will get the 1,2 diamine only. In this way, it is going to give you the reaction. This is your major product. Okay? Alright. So we have understood a lot of things, guys. Okay. Let's now do this simple conjugate addition revision. ये हमने पहले कर चुके हैं already, क्योंकि हम conjugate addition का पूरा session हमने देखा था. So what were the factors? Factors were कि let's say I am starting with the alpha beta unsaturated ester and I'm starting with the alpha beta acyl system, unsaturated acyl system. Who is going to give the direct and the conjugate addition? ये हमने पढ़ा था पहले भी. That is, if your amine has to attack on the acyl chloride, what will be the product? ये direct addition करेगा कि conjugate addition? Because Cl minus is a good leaving group. Because Cl minus is a good leaving group, it is going to give you direct addition. दूसरी चीज यहाँ पे क्या हो रहा है देखो, in the case of ester. Alright, in the case of ester, the bonds are going to open up like this. Why is it not giving you direct addition? Because OR minus is a bad leaving group, or I would say not a good leaving group. ठीक है, चलो समझ में आया. Next is, once again you have the same ketone. This time you have alpha beta unsaturated ketone system. Direct addition of methyl lithium. Always the methyl alkyl, कोई भी alkyl lithium हो, कोई भी grignard हो, always they are going to give you the direct addition. यहाँ अटैक करेंगे और अल्कोहल बना देंगे. Like this 3 degree alcohol. Okay, very well. लेकिन जो thiol है, thiol is going to kind of replace. Okay, just a second. ये यहाँ पे हमने simple ketone लिया है and this is forming the ester. Alright, I think that here it should, in this reaction, there should have been starting with the ester only. But anyways, it is going to do conjugate addition in this manner. और अगर ये ester है तो ester सही, यहाँ पे conjugate addition हो रहा है. Okay, हाँ थोड़ा सा यहाँ पे printing में problem है. The arrow is correct, everything is correct. There should have been the OR over here. Alright, yes. So this is what we were talking about. Most of the reactions we have done, and now we are going to apply the same concept to two of these important questions from the solution manual. Guys, पूरा chapter आपके पास है. आपको जितना अच्छा लगे उतना पढ़ो, right? And there are more and more and more of regioselective reactions which we cannot list in this 1 hour session, but there are huge number of reactions as such, right? So have a look out for them. Alright, so two routes are proposed for the preparation of this amino alcohol. This one, which do you think is more likely to succeed and why? मतलब कि इन दोनों में से कौन सा रूट सबसे सही है? Okay. Yes, I just hope you can see the question, isn't it? So you start with an yes, you start with a system like this. ये रहा हमारा starting material. ये process A है, ये process B है. So you have to tell me which process will give you the conjugate addition product. ध्यान से बोलना है आपको, because this is super important. Also consider all the possibilities. All right. So Ananya and Salesh. See, tell me guys, if let's say आपके पास amine है, a secondary amine. What can a secondary amine do? Either it can give you a conjugate addition or it can give you a direct addition as well. And tell me what is a greater possibility over here? Greater possibility is removal of this carbonyl and kind of give you the storquinamine. ये क्या बन जाएगा? इमीन बन जाएगा इस तरीके से. Is it possible? Yes, why not? For a secondary amine, formation of imine ion is possible. And NaBH4 is going to give you the imine reduction. एक hydride यहाँ से आएगा. It's going to give you imine reduction. तो आपका product तो ये होना चाहिए ना? Not this one. So A is wrong. A is wrong. अभी सब लोग B बोल रहे हैं. Yes, what happens if we think of the alpha beta unsaturated ester? चलो, see. First thing first, यहाँ पे ester का जो carbonyl है, that is not very electron deficient, as electron deficient as aldehyde. Why? Because it already has an oxygen जो इसमें electron density भर रहा है, so इसे जरूरत नहीं है nitrogen के attack की. So nitrogen is going to do the conjugate addition like this, and that's why this process is going to be much beneficial in option number B. One, two, and three. Alright, so you can just write it like this only. Okay, and finally लिथियम एल्यूमिनियम हाइड्राइड रिडक्शन, क्योंकि ये एस्टर है. एस्टर में कितने मोल्स चाहिए? 2 मोल्स चाहिए. वन हाइड्राइड अटैकिंग ओवर हियर टू गिव टू रिमूव दिस OMe, और एल्डिहाइड से फिर रिड्यूस करके इट्स गोइंग टू गिव यू अल्कोहल. सो या एब्सोल्युटली you require this in the B process. Okay, so yes, does it make any sense guys? Why is aldehyde doing the direct addition, ester not doing direct addition? Because of the electron deficient nature of the carbonyl carbon of the aldehyde. That is the reason. ठीक है? चलो. We'll do another question. So this is problem number 7 from chapter 24. Once again, वही जो हम regioselectivity पढ़ रहे हैं. First में double bond में क्यों attack नहीं हुआ स्पंदन? Because of the same reason. Same reason that your imine formation is more probable because the aldehyde carbon is more electron deficient as compared to the ester carbon. Yes, Alish, you say that can we say because of resonance direct addition is not possible? Actually, we say, in the case of ester, the carbonyl carbon is not very electron deficient. That is because of resonance only. So, yes, the amine would rather attack the double bond. Chalo. So, yes, what were we talking about? The sequence of reaction given below shows the preparation of a compound needed for the synthesis of a powerful anti-cancer compound. ठीक है. Explain the regioselectivity of reaction. So tell me what is happening in the first step. इसमें क्या हो रहा है ये बताओ सबसे पहले. Later we'll see the other one. Only tell me about the first step. What is happening? All right, Vishnu, very good. Yes, Pandan, chylation नहीं बोलेंगे इसको, ortholithiation बोलेंगे ना. It will be called as ortholithiation. Ortholithiation यहाँ से होगा. All right, this oxygen is going to Okay, there will be a lithium. कहाँ से आया lithium? Because एक OMe group था यहाँ पे, right? So connecting to that, you will have lithium and butyl group. So after that second reaction में methyl iodide पे attack कर देगा this phenyl ring, and the iodide leaves with lithium. So minus Lii. Okay, addition of methyl. ठीक है, ठीक है, चलो. What about the second one? You are taking two equivalents of butyl lithium and you are just taking one equivalent of this amine. What kind of amine is this? ये हो गया. All right, this is DMF, dimethyl formamide, dimethyl formamide, DMF. Okay, so two equivalents of butyl lithium and then a formylation group. क्योंकि DMF पे अगर attack होता है, nitrogen will be a good leaving group. CHO is added as it is. ठीक है, add हो गया है, very good. All right. So why two equivalents of butyl lithium? Why do we need that? अब सबको ही कुछ भी बोल रहे हो guys. Wilsmer hack reaction, manic reaction. It is nothing like that. You see DMF and you think about all these reactions. No. Wilsmer hack reaction के लिए POCl3 भी तो चाहिए. And that's a electrophilic aromatic substitution. That's correct. Here you're not doing anything like that. Here it's not even your electrophilic aromatic substitution. It is ortho lithiation. Electrophilic aromatic होता है ना Wilsmer hack तो. That is, you have a double bond and it's going to basically attack on the CHO, amine leaves, and regeneration of aromaticity. ये उस process से हो ही नहीं रहा है. It is not happening that way. What is happening? It is ortholithiation. That is, a negative charge is attacking. The ring is not attacking. The ring pi bond is not attacking. ये देखो. So, yes. Why do you require 2 moles of butyl lithium? Because here you have a CH3 जो कि इस ऑक्सीजन के बहुत ज्यादा क्लोज है. Very close to this oxygen. Absolutely hydrogen bonding नहीं हो रहा है ये. Don't consider this is hydrogen bonding. But the proton in the similar way, जैसे usually ortholithiation होता है, the proton could be removed and a lithium coordinated over here. So butyl lithium, one of them, will be used over here. Second butyl lithium is going to take away the proton from the another ortho position. ये फिर से ortholithiation हो गया है. और ये हमारा rule क्या है? Rule says the one which is formed last formed reacts first. ठीक है? Last formed reacts first. So this is going to react first. And do you understand? ये यहाँ पे negative charge attack कर रहा है. कोई electrophilic aromatic substitution नहीं है DMF पे. Okay. Negative charge is attacking. All right. So yeah, this is what you get through the ortholithiation. And after the whole aqueous workup thing, everything else, पूरा aqueous workup हो जाएगा तो ये lithium eliminate हो जाएगा with OH and another proton taken away by water to give you methyl. All right, a very simple reaction. Okay, so right, what do you think about it? It's not a Wilsmer hack reaction, no manic reaction. It's just the ortholithiation, back-to-back ortholithiation taking place. अब ये सारा का सारा regioselectivity ही तो है guys. Why the ortholithiation happens on the ortho position only? That's because of chelation. Okay. Second step में manic नहीं होगा, बिल्कुल नहीं होगा. There is no manic over here. What is a manic reaction? Manic reaction is one where you are generating this kind of a iminium ion. So this Eschen-Mosher salt we haven't generated over here. No manic. ठीक है? orthoregioselectivity because of the ortholithiation, the chelation process. ठीक है. So, all right, absolutely. This is your DMF. Guys, नेम रिएक्शन में एक बार मैनिक रिएक्शन देख लो. ठीक है. And we are done over here for today. So we did a very nice question over here and a lot of things. See, once again telling you regioselectivity is not limited. बहुत ज़्यादा vast है. So whenever you study any reaction, just notice what is the product and why is this the product. Just notice that. Chalo. So what should I do now? I should tell you the topic of your live quiz today. So today's topic will be organometallic chemistry. Once again, 12 noon is the live quiz which you only have to give live on Unacademy app. Okay? Yes. All right. Okay. No, no. Spandan, first you complete organometallic chemistry, then we come back to organic. Okay? All right. So guys, thank you so much for joining up in today's session. If you are liking the session, please share them with your friends and I'll see you very soon then. Bye, bye all of you.